Just a continuation of the last section, and this is called graphing exponential functions. So, hello, you want to take some notes? Be kind of ready to learn, and why are you dressed like that?
What?
Why do you have your hood on? Why are you kind of try to look like you're ready to be in school? Okay. So if you have an exponential function like we do here, this is kind of the general form of an exponential function. Okay, this thing here is the y-intercept. A is going to be your y-intercept, which is kind of interesting. Okay, if it looks like this, we'll talk more about that. In this case, A would be 1. Okay, so we'll talk a little bit more about that. This is called your growth. This is kind of the growth or decay factor, right? Growth or decay. Decay factor. And so if this is a number bigger than 1, your function's going like this. If this is a function less than 1, your function's going like this. So let's just graph one exponential function by hand. This one right here, or we're going to graph all of these by hand. So negative 3y. So 2 to the negative 3. This is a tricky one, okay? Because, well, let's start actually with 0. What's 2 to the 0 power? Anything raised to the 0 is equal to 1. Okay? 2 to the first power. To the first power. 2. 2 to the second power. 4. 2 to the third power. 8. Okay? So I'm going to graph these points on here. All right? So that says that when x is 0, y is 1. So I'm going to plug in 0, 1. Then I'm going to plug in 1, 2. Good. 1, 2. Then I'm going to plug in 2, 4, 3, 8. It's kind of going to look like that. Okay? But what about back here? Okay, as I go backwards. Do you guys, so if I define this one, what is 2 to the negative 1 power? Does anyone remember what that, how I could rewrite that from first semester? 2 to the 1. It's the same as what, Allie? It's not a negative number. What is it, Jessica?
It's the same as 1 over 2 to the 1.
Remember this? This is the same as 1 over 2 to the first power, which is just equal to what? 1/2. So when x is negative 1, this is 1/2. Right? 2 to the negative 2 is the same as 1 over 2 to the positive 2, which is the same as 1/4. Okay? So as I go backwards, okay, I get 1/2, which is kind of hard to graph there. 1/4, which is even harder to graph there. Okay? 1/8 would be the next. Whoops. What? Well, I'm trying to be as accurate as I can. If I plugged in negative 3, I would get 1 what? 1 what? What's 2 to the 3 power? 1/8, right? So I get these little numbers, and what I get is a function that looks, let's change the color. Ooh, this is a pretty color. Okay, I get a function that looks like this. Okay. Whoops, ooh, that was a bad slip of the pen. Okay, and let's try that again. Boom, boom. I think I have to sit to do this. Guys, so it's going to come down here. It's going to go through these points. And then it's kind of going to go like this. Is it ever going to touch the x-axis? No. This x-axis has a name. Anyone know what that name is?
X-axis.
It's got a better name. It's called an asymptote. Don't. Asymptote is a line that the graph gets close to but never touches. Okay? So it's an asymptote. Because no matter what number I plug in here, this y value is never going to be negative. Like if I put negative 100 in there, I get 1 over 2 to the 100th power, right? Which is a very, very small number, but it's not negative, right? So y is always going to be a positive number. So what you end up getting is an asymptote. Questions on that? Very excited about that? Hey, why are you doing? Oh, you're kind of writing it down. Are you writing that down there, Jay? Thank you. All right. You okay?
You didn't write it down.
I'm writing.
That's what happened.
All right. So let's move on to another one. Okay. We're gonna try. So 3 to the x. I'll tell you, it looks a lot like that one. Okay. 1/2 to the x. Let's look at this one. I don't want to do all of them just because I don't want to. It'll take too much time. We'll do like 3 of these. So what if I did this one? Okay. I'm going to take my graph. I can make it a little bit bigger. What you really want to do for these is make a table of values. Okay. And you can use a similar table to the one I just asked, where I'm going to go from -3, -2, -1, 0, 1, 2, and 3. Okay? So let's start off with the positive ones, because those are usually a little bit easier. Whoops, that's bad. That's okay. So we're going to take, what's 1/2 raised to the first power? 1/2 to the first power. No, it's just 1/2, right? What's 1/2? 1/2 raised to the second power. 1/2 raised to the second power. What's that equal to? 1/4. You square the top, square the bottom. What's 1/2 raised to the third power? 1/8. Okay? Before I start graphing these things, I'm going to go in the negative direction too. Okay? So, say I were to do 0. What's anything raised to 0 power? 1. Okay? So now let's go -1. What's 1/2? Does anyone remember this rule from first semester? What's 1/2 raised to the -1 power? You remember this rule? You could flip over the fraction and make it
2.
positive, right? Yeah, so this is equivalent to writing 2 over 1 raised to the positive 1 power, which is just what? 2, okay? This is equivalent to writing 1/2 raised to the -2 power, which is the same as 2 over 1 raised to the positive 2 power, which is 7. 4, right? What do you think this is? 8, okay? So now I'm going to graph this. I don't know how to get rid of this over here, so I'm just going to leave it over there, okay? And I'm going to graph these points from -3 up to, so I'm going to take I got to make an XY axis here. XY axis, I got to sit to make sure it's pretty. Where should I start? Do I ever have any negative values? Negative values for y? Do I ever have negative values for y? No. So I'm going to go like this. I'm going to make this axis over here the x-axis. I'm going to make this the y-axis. Okay? And the biggest number I have is 8. So I'm going to just scale it by, I guess I'll just scale it by, how should I do this? -3/8. -3. -3 up. Oh, you know what we did? We're going to start. Let's go by 1/8. Okay? So let's call this point. This is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. I'll show you why. Okay? So if I plug in 0, I get out. So this is the point 0, comma 1. This would be the point 1, comma 1/2. So on this axis, I'm counting by 1, 2, 3, 4. David, behave yourself. Okay? 1 and 1/2, which would be 4/8, like that. Okay? 2 and 1/4, which would be 2/8. 3 and 1/8, which would be here. What would I get if I plugged in 4? I would get out 1/16, okay? And then I get out 1/32, and then I get out. So this graph, even though it's this number in here is positive, right? This one is going downhill. I could also go backwards to -1. I get out 2, which is way up here somewhere. So this graph, if I connected the dots, would look something like this. Notice that it curves. Is it ever going to hit 0?
No.
Never going to hit 0 because that's called a decreasing exponential function. About like that. Okay? I guess it goes up steeper over here. More like that. Got that one?
Yeah.
We'll do one more on this page, and then I want to tell you some of the rules on the back page. Okay? So let's graph, not this one. Let's graph this one. 5. You know how to do this one already. But let's do it. So let me slide down a little bit. Can I slide down? Can I move this up? What can I do? Move it up? The whole thing up? Will it go up? Go up. No. Uh-oh. Let's undo whatever I did. What I just did. There we go. I don't know what happened. Uh-oh. Oh, I moved it down here. So let's graph y equals 5 to the 2x. I'll just grab a piece of graph paper, which might be easier anyway. Okay. Place, capture, and new page. So we're gonna graph. Move this over here. We're gonna graph y equals 5 times 2 to the x. Okay. And we're just gonna go table values. Y or x, y. When x is 0, what's y? When x is 0, what's y? How do you get that? With
2, 5,
right.
0, 1.
2 raised to 0 is 1 times 5 makes 5. When x is 1, what's y? 10. When x is 2, what's y? 20. When x is 3, what's y?
40.
8 times 5 is 40. Okay, so for this one, you're going to have to scale it kind of bigger. Okay, so I might count by tens, or yeah, let's count by 10. So this would be 10, 20, 30, 40, 50, 60, wait, 10, 20, 30, 40, 50, 60, 70, 80, right? Is that right? 80, there we go. So 4, would that be 80? 2 to the 4th power, that'd be even bigger than 80, wouldn't it? 2 to the 4th power is 60, no, that would be right, that's 80. Okay? So then you could plot these points, 0, 5, 1, 10, 2, 20, 220, right? 3, 40, 5, 80, okay? And I'll get an exponential function That kind of curves down. It goes up really steep over here, and then it goes through these points, and then it kind of curves through there. It won't hit 0. Okay, it'll keep going like this way along the x-axis. Did you sketch that one in? Sketch that one. Okay. All right, we're good? Can I flip over onto the back side now? Okay. I just want to tell you some rules about how you shift these things around. So that's the back side of this handout. Okay. And y equals a to the x plus c. What do you think this c does? So this is just general rules, how you shift things up or down. What do you think this does, plus c?
Up.
Moves it up, okay? So this moves up 5 units. Or, sorry, not 5 units, c units, right? C units. What do you think this does? Down C units. What do you guys think that this does? Think about your parabolas and stuff like that, or your, what is this negative C? Anyone know what this is going to do? Which way do you think that would shift it? Yep. This moves it, moves right C units. And this moves it which way? Moves it which way? Left C units. Okay. So then you can kind of try to graph some. Yes, sir.
What is it moving? Like
The whole graph. So if I have, so for example, we'll do an example. I'll show you. Okay. So
I get it.
no, I know, but
No.
it's just hard to.
I see.
No, my graph paper is annoying me. Can I move this thing?
I got it now.
No, I know, but I have to do an example. So if I have y equals 3 to the x plus 2 minus 1, this is going to move the graph left. You're going to graph 3 to the x, and then y equals 3 to the x, and then I'm going to move it which way? Move it left 2 and down 1. Okay? So I think I need to do that on a separate sheet of paper. Can I do that? Okay, sure you can. All right, so where is it? Oh, brother. Oh, here we go. Here we go. Okay, let's see if I can grab some graph paper, put it in here, partial. We're going to take this, okay? So if I have this one, y equals, so the way I could do this is by first graphing the line. Do this on your paper. David, do this. Again, this is never going to hit. This is never going to hit, if this is the x-axis, never going to hit the x-axis. Okay? Y equals 3 to the x. I'll show you 2 ways to do this. Okay? When x is 0, what's y? 1x, not 45. What's 3 to the 0?
3.
No.
1.
1. When x is 1, what's y? 3. When x is 2, what's y? 9. Let's do 1 on the opposite side. When x is negative 1, what's y? 3 to the negative 1 is 1 over 3. Okay? Now, if I were to graph y equals 3 to the x plus 2, that's kind of in parentheses, minus 1. That, given the same x and y values, it's going to basically move it left 2. So I would be subtracting 2 from this and nah, let's not explain that. Okay. So let's graph this first, okay? 0, 1, 1, 3, 2, 9, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, and negative 1, 1/3. So this is this graph right here. Now I'm going to take all these points, and this is going to be, we said it's left 2, down 1, right? So I could take this, let's take an easy point, left 2, 1, 2, down 1. I'll do the new points in blue. So I'm going to take this point, move it left 2, and down 1. Good. I'm going to take this point, move left 2, down 1. I'm going to take this point, move it left 2, and down 1. And I'm going to take this point right here. I'm going to go left 2, down 1. Do you guys understand what I just did? Yes, sir.
So if you're moving it left 2 and down 1, it does cross the x-axis?
You're very good. Well, yeah, except it has a new asymptote. I'm going to draw that in right here. Okay? So if I were to draw a dotted asymptote, right, down here, it just shifts that x-axis down 1, you see? So you'd have a new asymptote down here, okay? And this one, what color should I make it? We'll make it blue. So the new graph looks something like, whoops, I missed. Looks something like that, all right? Okay, so back to it. So do you understand what I just did? All those points get shifted left 2 and down 1. I think, I'm just going to look at the next one really quick. So say I were to do this graph, 1/3 x minus 3, what's it going to do to this graph? Which way is it going to move? What's this negative 3 going to do to it? Right. It's going to move it right 3, and what's this going to do to it? Up 2. So if I know that this graph, real quick, I'm not going to graph all the points. So if I know at the first graph, remember when we graphed 1/3, it kind of, y equals 1/3 to the x. I would graph y equals 1/3 to the x, which would kind of look something, it would be going downhill. That's 1/3 to the x. So if this is y equals 1/3 to the x, then I would take that whole graph, I move it over 3 and up 2. So it'd be kind of like somewhere up here. You get that idea? So when you do them for your homework, you only have, I think, 4 graphs to do? 4 graphs? How many graphs do I? Maybe I forget how many. But I don't want you to just sketch them. I want you to actually plot points. Okay? So I'm going to stop.
Oh, it's just
Because that was a lot.